The ocean covers more than 70% of our planet, yet we've explored less than 5% of it. What lies beneath the crushing darkness miles below the surface? Today, we dive into the deepest secrets of the Earth's oceans. This is The Depth, and these are 29 mind-bending ocean facts you won't believe. Imagine standing at the summit of Mount Everest, the highest point on our planet. Now, imagine taking that entire mountain and plunging it into the ocean. It wouldn't even touch the bottom of the Mariana Trench. The deepest part of that trench, the Challenger Deep, is a staggering 36,000 feet, or nearly 11,000 meters, below the surface of the Pacific Ocean. That's almost 7 miles straight down. If you dropped a 1-pound weight from a boat above, it would take over an hour to finally settle on the sea floor. This isn't just deep, it's a completely different realm of our own world, hidden beneath the waves. At that depth, the rules of our world no longer apply. The weight of all that water creates a pressure that is almost impossible to comprehend. It's over 1,000 times greater than the pressure we experience at sea level. To put that in perspective, it's like having 50 jumbo jets stacked on top of you. For a human, this pressure would be instantly fatal. It's so immense that it can compress steel and turn ordinary objects into dust. This environment is one of the most hostile and unforgiving places imaginable, a true testament to the power of nature. So, you'd think nothing could possibly survive down there, right? Well, prepare to be amazed. In this world of eternal darkness and bone-crushing pressure, life finds a way. Scientists have discovered a bizarre and fascinating ecosystem thriving in the Challenger Deep. We're not talking about giant sea monsters, but the life that exists here is arguably even more incredible. Tiny, single-celled organisms called foraminifera, strange-looking worms, and ghostly, shrimp-like creatures called amphipods have all adapted to this extreme environment. They've evolved unique biological systems to withstand the pressure and navigate a world without a single ray of sunlight. The temperature in the Challenger Deep adds another layer of extremity. The water is perpetually near freezing, hovering at a chilling 1 to 4 degrees Celsius. It's a frigid, stable environment. But this cold darkness is punctuated by scenes straight out of a sci-fi movie. Hydrothermal vents, like underwater geysers, spew superheated, mineral-rich water from the Earth's crust. The temperatures at these vents can skyrocket to over 400 degrees Celsius, hot enough to melt lead. It's a place of shocking contrasts, where freezing cold and blistering heat exist side by side, creating unique chemical cocktails that support these hidden ecosystems. For most of human history, the Challenger Deep was a place of myth and speculation. It wasn't until 1960 that humanity made its first journey into this abyss. Two brave explorers, Swiss oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh, descended in a specially designed submersible called the Bathyscaphe Trieste. Their journey was a monumental feat of engineering and courage. They spent about 20 minutes on the bottom, peering through a tiny, thick porthole into a world no human had ever seen before, proving that it was possible to reach the deepest frontier on our own planet. Since that historic dive in 1960, how many people do you think have returned to the Challenger Deep? You might be surprised to learn that it's an incredibly exclusive club. As of today, fewer people have been to the bottom of the Mariana Trench than have walked on the moon. While 12 astronauts have left their footprints on the lunar surface, only a handful of individuals have personally witnessed the bottom of our own world. This highlights just how challenging and dangerous exploration of the deep sea truly is. In many ways, it's a frontier that is more difficult to access than outer space. The Mariana Trench isn't just a single deep hole. It's a massive geological feature. It's shaped like a crescent moon, stretching for over 2,500 kilometers, or 1,550 miles, across the floor of the western Pacific Ocean. That's longer than the Grand Canyon. This colossal scar in the Earth's crust was formed by a process called subduction, where one tectonic plate, the massive Pacific Plate, is slowly being forced underneath the smaller Mariana Plate. It's a dynamic and active part of our planet's geology, a place where the very surface of the Earth is being recycled. And what does it actually look like down there? Based on the few images and sonar scans we have, it's a landscape unlike anything on the surface. Forget sandy beaches. The floor of the Challenger Deep is a fine, silty ooze made from the compressed shells of countless microscopic creatures that have rained down from the waters above over millions of years. But it's not all flat. This alien world is dotted with massive mud volcanoes spewing liquid and gas, sharp, jagged ridges, and strange geological formations. It's a silent, dark, and profoundly isolated landscape, holding secrets about our planet's history and the limits of life itself. Exploring the Challenger Deep is more than just an adventure, it's a scientific necessity. Every dive brings back new data, new species, and new questions. By studying this extreme environment, we can learn about how life might exist on other planets, understand the processes that shape our own world, and uncover new biological compounds that could lead to medical breakthroughs. The Challenger Deep is a reminder that there are still vast, unexplored frontiers right here on Earth, full of wonders waiting to be discovered. A world of crushing pressure, bizarre life, and landscapes that defy imagination. Imagine a world where the only light comes not from the sun, but from the creatures themselves. This is the reality of the deep sea. Many animals living down there have an incredible superpower called bioluminescence. They create their own light, glowing in the crushing darkness to attract a meal, find a mate, or startle a predator. It's a living light show happening miles beneath the waves. Speaking of incredible creatures, have you ever heard of the Dumbo octopus? No, it's not a cartoon character, but it might as well be. This adorable octopus gets its name from the two large, ear-like fins on its head that flap just like the ears of Disney's famous elephant. It gracefully flies through the abyss, a truly enchanting sight in a world of extremes. But what does the deep sea sound like? Well, it's anything but silent. Sound travels about 5 times faster in water than it does in the air. This makes the sounds of the deep incredibly powerful and far-reaching. The calls of whales, the clicks of dolphins, and other unknown noises create a soundscape that's both eerie and beautiful, a constant conversation happening in the dark. This brings us to one of the ocean's greatest mysteries, a sound known as the bloop. In 1997, scientists detected an ultra-low-frequency, extremely powerful underwater sound. It was so loud that hydrophones over 5,000 kilometers apart picked it up. The sound profile didn't match any known man-made or geological source, so naturally, imaginations ran wild. For years, the public and even some scientists speculated that the bloop was the call of a colossal, undiscovered sea monster, something far larger than even the blue whale. The idea of a real-life kraken lurking in the abyss was captivating. It was the ultimate mystery from the deep, fueling countless documentaries and campfire stories. But, as is often the case with science, the truth was just as fascinating, though a bit less monstrous. After years of research and with more advanced data, scientists were able to trace the source of the bloop. It wasn't a giant creature. It was the sound of a massive ice quake, an enormous iceberg cracking and breaking away from a glacier in Antarctica. The sheer power of nature creating a sound so immense it was mistaken for a monster. Even without mythical sea monsters, the deep sea holds environments that are truly alien. Take deep-sea hydrothermal vents, for example. Nicknamed black smokers, these towering chimney-like structures spew out superheated, mineral-rich water from beneath the Earth's crust. The water is hot enough to melt lead, yet an entire ecosystem thrives around them. How is this possible without sunlight? It's all thanks to a process called chemosynthesis. Instead of photosynthesis, which uses sunlight for energy, the life forms here, like giant tube worms and strange-looking crabs, rely on chemical energy from the compounds shooting out of the vents. They found a way to build a world based on the planet's internal heat rather than the sun's external light. It's a completely different rulebook for life. And when we talk about the absolute deepest parts of the ocean, we enter the Hadal Zone. This zone starts at a depth of 6,000 meters or about 20,000 feet and plunges down into the ocean's trenches. Its name is fittingly derived from Hades, the Greek god of the underworld. It's a realm of unimaginable pressure and eternal darkness, the final frontier on our own planet. The pressure in the Hadal zone is over 1,000 times what we experience at the surface. It's like having the weight of 50 jumbo jets stacked on top of you. Yet, even here, life persists. Creatures like the Mariana snailfish have adapted to thrive under these crushing conditions, proving that life is incredibly resilient and tenacious. The deep sea is not just a dark, empty void. It's a dynamic world of living lights, mysterious sounds, volcanic oases, and creatures tougher than we can imagine. Every dive brings new questions and reveals new wonders, proving that the greatest adventures aren't always in outer space, but right here, in the depths of our oceans. Now we're talking about a place so extreme, so alien, that it feels like another world entirely. This is the Hadal Zone, the ocean's final frontier, extending from 6,000 to nearly 11,000 meters below the surface. Named after Hades, the Greek god of the underworld, this realm is defined by crushing pressures, freezing temperatures, and absolute darkness. It's a world of deep-sea trenches, canyons carved into the seafloor where tectonic plates collide. For a long time, we thought life couldn't possibly exist here. But, as we'll soon discover, life finds a way, even in the most unforgiving environments on Earth. Let's talk pressure. Imagine the weight of 50 jumbo jets stacked on top of you. That's the kind of pressure we're dealing with in the Hadal Zone, over 1,000 times what we experience at sea level. This immense force would instantly crush any land animal, and even most submarines. So, how does anything survive? Deep-sea creatures have evolved incredible adaptations. Instead of gas-filled swim bladders which would collapse under the pressure, many fish have gelatinous, water-filled bodies that are nearly incompressible. Their cells are packed with special molecules called piezolites, which protect their proteins and membranes from being squeezed into oblivion. It's a masterful feat of natural engineering, allowing them to thrive where we can't even visit without a multi-million-dollar submersible. And it's not just the pressure, it's the cold. Temperatures in the Hadal Zone hover just above freezing. To survive this perpetual chill, some fish have developed a kind of natural antifreeze. No, they're not sipping on coolant. They have special proteins in their blood that bind to ice crystals and stop them from growing, preventing their bodies from freezing solid. One of the most famous residents of this icy abyss is the Mariana snailfish. This small, ghostly white fish is the deepest living fish ever discovered, thriving at depths of over 8,000 meters. It's a true testament to the resilience of life, a delicate-looking creature that has mastered one of the harshest environments on our planet. In a world without sunlight, where does the energy for life come from? The answer is a process called chemosynthesis. Instead of photosynthesis, which uses sunlight, organisms here rely on chemical reactions. At hydrothermal vents, cracks in the seafloor spewing superheated, mineral-rich water, entire ecosystems flourish. Bacteria and other microbes convert chemical like hydrogen sulfide, which is toxic to most life, into energy. These microbes form the base of the food web. Larger animals, like giant tube worms that can grow several feet long, have a symbiotic relationship with these bacteria. The worms provide a safe home, and the bacteria provide the food. It's a completely self-sustaining world, powered not by the sun, but by the Earth's own inner heat. You might think that down in the pitch-black depths, eyes would be useless. And for many creatures that's true. A lot of Hadal species are blind, but others have evolved enormous, highly sensitive eyes designed to capture the faintest glimmers of light. Where does this light come from? Bioluminescence. Many deep-sea animals can produce their own light, creating dazzling displays in the dark. They use it for everything: to attract prey, to startle predators, to find mates, and to communicate. Imagine a world filled with living lanterns, flashing and glowing in an otherwise black void. From the spooky-looking anglerfish with its glowing lure to swarms of sparkling shrimp, the Hadal Zone is home to a silent, mesmerizing light show. The giants of the deep are not just in storybooks. Meet the giant amphipod. While most amphipods are tiny, rice-sized crustaceans you might see at the beach, their deep-sea cousins can grow to be the size of a dinner plate. These supersized scavengers are a prime example of a phenomenon called abyssal gigantism, where deep-sea species grow much larger than their shallow water relatives. Why does this happen? Scientists have a few theories. The extreme cold might slow down their metabolism, allowing them to live longer and grow larger. The high pressure might also play a role, or perhaps it's an adaptation for a feast or famine lifestyle, where being bigger means you can travel farther to find food and store more energy when you find it. Let's dive deeper into some of the incredible creatures that call this place home. Besides the snailfish and giant amphipods, we have the Dumbo octopus, named for the ear-like fins on its head that it flaps to gracefully glide through the water. There are also sea cucumbers, but not as you know them. Some deep-sea species, known as sea pigs, have leg-like appendages and roam the seafloor in herds, vacuuming up organic matter. And then there are the terrifying-looking but fascinating viperfish and dragonfish with their oversized jaws and needle-sharp teeth, perfectly adapted for snatching a meal in the dark. Every expedition brings new surprises, revealing a biodiversity that we are only just beginning to understand. Exploration of the Hadal Zone is one of the greatest technological challenges of our time. It requires remotely operated vehicles, or ROVs, and human-occupied vehicles, or HOVs, built to withstand the colossal pressures. These submersibles are our eyes and arms in the deep, equipped with high-definition cameras, robotic manipulators for collecting samples, and a suite of sensors to measure the environment. Every single dive is a high-stakes mission. It took until 2012 for the third person in history, director James Cameron, to make a solo dive to the Challenger Deep, the deepest point in the Mariana Trench. These missions are incredibly expensive and complex, but they are essential for unlocking the secrets of this hidden world. And the secrets are plentiful. Every time we send a probe down, we find something new. In the last decade alone, scientists on deep-sea expeditions have discovered over 200 new species. These aren't just minor variations. We're talking about entirely new branches on the tree of life. New species of fish, crustaceans, jellies, and worms, each with unique adaptations that challenge our understanding of biology. It's a thrilling reminder that even in the 21st century, our planet is still full of unexplored frontiers and undiscovered life. We know less about the seafloor than we do about the surface of Mars, and these discoveries highlight just how much is left to learn about our own world. But with discovery comes a sobering reality. Our impact has reached even the most remote and inaccessible places on Earth. Tragically, plastic pollution has been found in the deepest trenches. Microplastics, tiny fragments of our discarded waste, have been discovered in the sediment of the Challenger Deep and even inside the bodies of Hadal creatures like amphipods. It's a shocking and heartbreaking revelation. A place that has been pristine for millions of years is now contaminated by our actions. This serves as a powerful and urgent call to action, reminding us that our responsibility to protect the planet extends from the highest mountains to the very deepest parts of the ocean. It's important to remember that the deep sea is not a static, unchanging void. It's a dynamic and active environment. Some trenches, like the Tonga Trench in the South Pacific, are still being formed right now. This is a subduction zone, where the Pacific Plate is diving beneath the Tonga Plate. This colossal geological process causes earthquakes, shapes the seafloor, and is constantly reshaping the crust of our planet in real time. Studying these active trenches helps us understand the fundamental forces that drive plate tectonics and shape the world we live on. Now, let's talk about the deep ocean trenches. These aren't just deep valleys in the seabed. They are the planet's recycling centers. Imagine two colossal tectonic plates, grinding against each other for millions of years. This epic collision forces one plate, the dense ocean crust, to dive deep into the Earth's fiery mantle. It's a process called subduction, constantly reshaping the surface of our world, melting old rock to create new land. This is geology in action, on a scale that's almost impossible to comprehend. Now, let's talk about pressure. Down in the Mariana Trench, the deepest part of the ocean, the pressure is over 1,000 times what we experience at sea level. It's like having the weight of 50 jumbo jets stacked on top of you. To put that into perspective, if you took a submarine made of solid titanium down there, even the tiniest, most microscopic flaw in its structure would cause it to implode instantly, crushed like a soda can. The sheer force is immense, creating an environment that seems utterly hostile to life. It's a realm of extremes, where the rules of physics as we know them are pushed to their absolute limits. So, how could anything possibly survive? You'd think these crushing depths would be a barren wasteland, but you'd be wrong. Life, in its infinite creativity, has found a way. But life here operates on a completely different time scale. Forget the frantic pace of the surface world. Down in the eternal darkness, life moves in ultra-slow motion. Some creatures, like the Greenland shark, are thought to live for over 500 years, making them the longest living vertebrates on Earth. Think about that. A single animal that has been swimming in the deep since before Shakespeare wrote his plays. This slow pace of life is a survival strategy. With scarce food and freezing temperatures, conserving energy is everything. They grow slowly, metabolize slowly, and live for an incredibly long time. It's a testament to the sheer resilience of life, adapting and thriving in conditions we can barely imagine. And these aren't just biological curiosities. They could hold the key to our own future. Scientists and biologists are incredibly excited about the potential hidden within these deep-sea organisms. Because they live in such extreme conditions, high pressure, no light, and unique chemical environments, they've evolved completely unique biological tools to survive. We're talking about special enzymes that function under immense pressure and biological compounds that could be unlike anything we've ever seen. Researchers believe these unique adaptations could lead to groundbreaking medical discoveries. Imagine new antibiotics derived from deep-sea sponges, or even compounds that could help in the fight against cancer. The deep ocean is like a massive, unexplored library of genetic information, and each new species we discover could contain a chapter that revolutionizes modern medicine. Beyond medicine, the deep ocean plays a colossal and often overlooked role in keeping our entire planet stable. It's a key player in regulating Earth's climate. How? Through carbon storage. The ocean acts as a giant carbon sink, absorbing massive amounts of carbon dioxide from the atmosphere. When marine life in the upper ocean dies, it sinks, carrying that carbon with it down into the abyss. This process, known as the biological carbon pump, effectively locks away carbon in the deep sea for thousands, even millions of years. Without this natural service, the amount of CO2 in our atmosphere would be much higher, and our climate would be drastically different. The deep ocean is our planet's silent guardian, working behind the scenes to maintain the delicate balance that allows life to flourish on the surface. The exploration of these trenches is one of humanity's greatest modern adventures. It requires cutting-edge technology and incredible courage. Manned submersibles, like the Deep-Sea Challenger piloted by James Cameron, and robotic remotely operated vehicles, or ROVs, are our eyes and ears in this alien world. These missions are fraught with danger and technical challenges, but the rewards are immeasurable. Every dive brings back new data, new images, and sometimes entirely new species that defy our understanding of biology. We've seen bizarre fish with their own built-in headlights, ghostly octopuses, and strange, gelatinous creatures that seem to belong to another planet. We are literally charting the last unknown frontiers of our own world, and we've only just scratched the surface. What's truly mind-boggling is how much we still don't know. It's estimated that we have explored less than 5% of our planet's oceans. Think about that. Over 95% of the underwater world remains a complete mystery. There are likely entire ecosystems, countless species, and geological wonders waiting to be discovered. Imagine a mountain range, but inverted. A massive scar on the planet's crust, plunging deeper than Mount Everest, is tall. This is the Mariana Trench, the deepest part of any ocean on Earth. The pressure here is over 1,000 times what we experience at sea level. It's like having the weight of 50 jumbo jets stacked on top of you. It's so intense that it can literally warp steel and crush most submarines like a soda can. The temperature hovers just above freezing, and sunlight has never, ever touched these depths. It is the definition of an extreme environment. For a long time, we assumed nothing could live here. But we were wrong. In 1960, the bathyscaphe Trieste made its historic dive into the Challenger Deep, the trench's lowest point. Peering out of their tiny viewport, the two-man crew saw something that changed our understanding of life forever. A flatfish, swimming calmly in the crushing darkness. Life existed at the very bottom of the world. That single observation opened up a whole new field of science, proving that life is more resilient, more adaptable, and far more bizarre than we could have ever imagined. The abyss was not empty. It was waiting. So, how does life survive in a place with no sunlight, crushing pressure, and freezing temperatures? It gets creative. Forget photosynthesis, the process that powers most life on the surface. Down here, life runs on a different kind of fuel: chemistry. Scattered across the deep sea floor are hydrothermal vents, often called black smokers. These are like underwater geysers, spewing superheated, mineral-rich water from beneath the Earth's crust. These vents are oases in the deep-sea desert. Instead of sunlight, entire ecosystems here are built on chemosynthesis. Specialized bacteria convert the toxic chemicals gushing from the vents, like hydrogen sulfide, into energy. And where there are bacteria, there's a food chain. Giant tube worms, some over 6 feet long, with vibrant red plumes, have no mouth and no digestive tract. They rely entirely on these symbiotic bacteria living inside them to produce their food. Blind white crabs scuttle over the seafloor, and strange pale fish navigate the darkness. It's a bustling city of life, powered not by the sun, but by the very heat of the Earth itself. These discoveries suggest that life might exist on other worlds, like Jupiter's moon Europa, which is believed to have a liquid ocean and hydrothermal vents beneath its icy shell. The creatures of the deep are masters of adaptation. To cope with the immense pressure, their bodies are often gelatinous, composed mostly of water, which is nearly incompressible. This allows them to maintain their shape without being crushed. The Mariana snailfish, for example, lives deeper than any other known fish. It looks incredibly fragile, almost ghost-like, but its soft, boneless skull and gelatinous body are its secret weapons against the pressure. And then there's the darkness. In a world without light, animals have evolved incredible ways to see, communicate, and hunt. The primary tool? Bioluminescence, the ability to produce your own light. This isn't just a faint glow, it's a complex language. Some creatures use it to attract prey, like the anglerfish with its famous glowing lure dangling in front of its terrifying mouth. Others use it to startle predators, releasing a burst of light like a flashbang to make a quick escape. Some even use it to find mates, flashing specific patterns in the eternal night. The deep sea is a constant light show, a silent, sparkling symphony performed by its inhabitants. It's a world painted not with sunlight, but with living light. The bottom of the ocean isn't just home to strange creatures, it's a library of Earth's history. Down in the deepest trenches, where the water is calm and undisturbed, layers of sediment have been slowly accumulating for millions of years. Each layer is a snapshot in time, trapping microscopic fossils, volcanic ash, and chemical clues about the planet's past climate. By drilling core samples from these sediments, scientists can read the Earth's history like the pages of a book. They can learn about past ice ages, shifts in ocean currents, and major extinction events. These deep-sea trenches are like time capsules, perfectly preserving a record of our planet's dramatic past. In the silent, dark abyss, we can uncover the stories of ancient oceans and the forces that have shaped our world over millennia. It's a geological archive of immense importance, holding secrets that can help us understand not just the past, but also the future of our planet. Yet, for all our wonder and exploration, we've brought our own ghosts to the abyss. In 2019, explorer Victor Vescovo piloted his submersible, the Limiting Factor, to the very bottom of the Challenger Deep, setting a new record for the deepest solo dive. What he found there was both awe-inspiring and heartbreaking. He discovered several new species of crustaceans, creatures never before seen by human eyes, a testament to the undiscovered life still waiting in the deep. But alongside this incredible discovery, he found something else, something depressingly familiar: a plastic bag. That single piece of trash, lying at the deepest known point on our planet, is a stark and powerful symbol of our impact. It's a reminder that no place on Earth is untouched by human activity. Our pollution has reached the most remote, most inaccessible corners of our world before we've even fully explored them. The final frontier is no longer pristine. It's a sobering thought that our legacy, found in the deepest, darkest part of our own planet, is our garbage. This brings us to a rather humbling reality. We have poured billions into space exploration. We have sent rovers to Mars and probes beyond our solar system. As a result, we have a more complete, high-resolution map of the surface of Mars than we do of our own planet's sea floor. It's estimated that over 80% of our ocean remains unmapped, unobserved, and unexplored. Think about that. We know more about the geography of another planet millions of miles away than we do about the majority of our own world. Why is this? The deep ocean is an incredibly challenging environment. The pressure, the darkness, and the sheer scale of it make exploration slow and expensive. We look up at the stars searching for life, but maybe the real aliens are already here, hiding deep below the waves. This is the depth, where knowledge runs deep. Like, share, and subscribe, because this is just the beginning.